Um, okay, everybody enjoying Pycon UK so far? Yeah. Woo! Who's here for the sprints tomorrow? Yeah, woo! My favourite part of the week. Right, are you ready?
I'm ready.
We're going to have our first lightning talk by Cesar Descaldes on ascending a Swiss summit.
So, hello everyone. This is an invitation to ascend a Swiss summit. This is the Eiger, also known as the Widowmaker. But this is not the one you're going to ascend. It's the Swiss Python. The Swiss Python Summit next year. It's going to take place in a place close to Zurich in February. It's going to be in English. You know, we speak French, German, and Italian, so it was hard to come up with a common language. So I heard Brits love Switzerland, like for instance James Bond, Sherlock Holmes as well. Yeah, I heard. We have a lot of things in common. So we have great talks, like last year. This year we had a French person doing, he couldn't do live music, but he was enhancing his musical instruments to do something really crazy with Python. We had somebody from astrophysics background explaining things that I think I understood, but maybe not. We have great views, so it's only one day, and then from there on you can move. Everything is within 2 hours reach. And then we have glaciers as well. It's gonna be snow sports seasons, so you can do snowboarding, ski. I heard the British like chocolate. Well, the Swiss eat even more chocolate than you. And the flag is so please join us, give a talk, attend, contact us. Thank you.
Brilliant. Thank you very much.
So, hello, I'm Filip, I come from Poland, and I will talk about PyCon-PL. So, PyCon-PL is the oldest Pycon in Central Eastern Europe, so it's, this year we will have 9th edition of PyCon-PL. And it's also one of the oldest Pycons in Europe and 6th oldest Pycon in the world. So, PyCon-PL takes place in very strange places, I would say, because most of people ask why it's not in Warsaw or Krakow or other big cities. And the reason behind that is that we kind of introduce a different idea, different concept, that we choose small towns and villages instead of big cities. So, we usually choose some big hotel complex which can fit all the attendees, so around 500 or more. And what are the advantages of such approach? So, as everything is one place, so the conference, accommodation, meals, socializing, then you don't need to worry about getting between places in a city. You don't need to worry about the weather because when you leave the room, you can go straight to the conference without even going outside. You can theoretically go in pajama for the talks, but I don't recommend it. So everything is close. If you forgot something, then you can easily go back. And it gives superb socializing and unique atmosphere. So here are some pictures from previous Pycon PLs. So as you see, views are really great. So we usually choose some places near some nice mountains or forests. And this year it will happen in Ossa. So it's happening next month. So where exactly is Pycon PL and Ossa? So it's in a village. And this is the hotel complex, which is really huge. It could even fit 1,000 attendees, but we don't have so much. So, and walking around it, you can get fit. It's about 1 hour from Warsaw and the international airport. And you can easily go using our bus transfers that go 2 hours before the start of the event if you don't have your own car or you are traveling from abroad. I think there are many options to go from UK to Warsaw. I did a quick research regarding the prices. So we have 5 tracks. We have 2 English tracks, 1 Polish track. We have workshops. Of course, Lightning talks. We are expecting about 100 attendees. And what is important, full ticket includes hotel room plus meals during the conference. So this is the auditorium. We also have a PyLadies workshop, and we are looking for sponsors. So if you would like to sponsor PyLadies workshop, we would be very happy. And we have a lot of other activities like coding challenges, board and card games, retro zone, and many more. So coding challenge 10 p.m., coding challenge near the morning, some board games, card games. This is the main hall with the main track. We have really nice place where to eat meals. Everyone can sit. There are no 2 phases, A and B. We have a free swimming pool, a sauna and jacuzzi. Also other stuff like bowling alley, squash, snooker. These are the rooms. And I would say it's relatively cheap. I don't know if you agree, especially that the prices include meals and accommodation and the conference ticket itself. So fantastic atmosphere which you want to experience. Dance floor at 5 a.m. We have also some ambassadors, so you can poke ambassadors and ask about the conference. How do they feel about it? And they probably can also give you some tips regarding the event. And there's Nicholas from UK. So come and attend Pycon PL. You can find more details and talks, also keynotes on the website. So thank you.
I do have to admit that I just let him finish in order to see what would happen. Next VGA, is it Jim? Yep. Got any more VGAs left? No? Great. Thank you. High-tech thing next. So.
I guess you plug this thing in. Oh, shit. You know what? You hit enabled. So I should explain. This is it's a Dell running Debian Unstable. Ooh. And it's just worked perfectly with the projector in room D. Right, I'm kind of tempted.
Do you want to come back at the end?
Yeah, tell you what, should we try that?
Yeah.
Give me a moment, because I do actually have a spare laptop.
Okay. Well, if I let the others do their talks first, and then
do that. Let's do that.
come back at the end. Right. So, where's my man? Can we have HDMI?
Can you put the timer on?
Yes, I can. Yes. And yes, that's your computer coming up. Would you like the hand mic?
Thank you.
Tropical fish. I'm kidding, this one does have words in it. My name is Adam Obeng. I'd like to talk to you about a thing called Goldfish, which is a Python package, but more than that, it's a question that I have for you. I'm presenting because I want to know if this is something that is a really bad idea or a really good idea, whether it solves a problem that other people have or just a problem that I have. And when I was preparing this Lightning talk, I didn't have an answer to those questions, but having attended Pycon for a little bit, I now kind of do. So here's the problem that I face. I'm something like a data scientist, and often we develop pipelines to process data where we have some functions we need to apply to some data files, and those functions depend on other functions, and often running the functions takes a long time. But because we're iterating on the analysis as we go along, both the code and the data can change at any time, and we might have multiple versions of the code running on the same machine in different places at different times. And you might need to, in this case, you would need to rerun process data if you got a new version of the data file, or if you decided to change how the data cleaning happened. But because it takes a long time to run this, we only want to run it again if absolutely necessary. So what Goldfish kind of tries to do is to streamline this process by using memorization and caching our intermediate results and only rerunning the functions when absolutely necessary. So this is an example of a kind of long-running function to sum the first 20 million numbers written in a very naive way. So if I try to run this, it takes a couple of seconds. What I can do with Goldfish is put a decorator in front of this function. So let me put down the mic to do that. So I run that again, and the first time it takes still the same amount of time to run, but the second time I run it, it's actually instant because it's reading from the cache. So that's nothing new. That's just Memorizer. It exists in computer science classes. There are lots of Python packages that actually implement that. But where Goldfish is kind of sort of new, somewhat, is that it's a persistent Memorizer. So if I open another Python interpreter, like another IPython notebook here, and run the same function, I get the result instantly. But that's also not very new. There are persistent memoizers that exist in Python. The thing I suggest is that what Goldfish does is it treats file arguments specially. So if we have this function which averages the integers in a file, which is decorated, we get back one result. If we go and modify that file, so it's here in this tab, so let's add some zeros to this line and save it, and we run it again, we get back a different result because we haven't got the old cached value in there because Goldfish has noticed that the file has changed. We could do a similar thing with memorizing function arguments. So this first function applies the function you give it as an argument to this list of primes. So if we double the list of primes, we get back 4, 6, 10, 14, etc. If we change what the double function is, we get back the new values. So Goldfish has paid attention to that. Limitations of this. As the old joke goes, there are two hard problems in computer science, and the first one is cache invalidation. It's very difficult to know when you should return a new value as opposed to the old one. And there are a number of problems with I/O and random numbers and so on. But so originally I was going to end this by saying, get in touch with me if you're interested in this, and maybe try to install Goldfish. But as it turns out, there's another much better developed project called Recipe, developed by this person here. Which does almost everything I need it to, and I found out about thanks to Pycon. So don't download Goldfish, contribute to Recipe, I will be.
Ah, hang on. Oh, that's going to go handy, isn't it? Just a second.
Don't forget the videos of all the, most of the conference has already been put on YouTube, or is being put on YouTube. So don't forget to look at the talks that you had to choose against.
Perfect, thank you. Oh, I've got an extra microphone. Is that one working? Maybe not. Right, okay. Hi guys, so thank you very much for that comment about Recipe. I'm not actually going to talk about Recipe now, so I talked about that yesterday or the day before or whenever it was. But I want to talk about Xray briefly. First of all, disclaimer, I'm not the author of Xray. I didn't create it. I'm not anywhere near clever enough to do that. But I think it's really cool, and I think more people should know about it. So, Xray is a Python module often imported as XR. And I just want to give a brief example of what it can do. It gives you the power of pandas for multi-dimensional array datasets, which pandas itself doesn't handle very well. So here what we're doing is we're loading in a netcdf file containing measurements of air pollution over the UK. This is PM 2.5, air pollution over the UK. And it's got gigabytes and gigabytes of data in there. And if we load it in and we look at the object we get, look at the shape, for example, it looks fairly standard. It looks like it could be a NumPy array or something. You've got 3 dimensions, fairly understandable. But you can look at the dimensions and you can find out these dimensions have names, time, y, and x in this case. And in fact, you can get a lot more information from this with the sort of metadata that's stored about the different dimensions, which allows you to do something quite cool like this. So this line of code takes the PM 2.5 data, it groups it by the season. So in terms of meteorology and atmospheric sciences, we talk about winter and summer and spring and autumn, and they're all assigned different months of the year. We can take that, and we can do a mean over time for each of those different dimensions. And with a little bit of extra code, we can plot this and get something like that with about, 3 lines of code overall, which is an awful lot easier than dealing with this in NumPy manually and going, okay, so we want to get winter. Now that's December, January, February. If we start at index 1392 and then go on, and then you go to leap years and you just get very confused in the end. So just a very brief demonstration of how it works. If you create like a random NumPy array, you can stick it into a data array and it's really simple. It comes up with some automatically named dimensions. That's kind of not very useful though, so you can move to something a bit more complicated and just give them names, which just helps you know what you're dealing with and what you're averaging over, what axes you're using. You can take it a bit further and actually give different coordinate values. So you've got integer coordinates, floating point coordinates, and date-time objects there. It inherits from lots of pandas functions for dealing with date times effectively. If you look at that, you've got a load of interesting metadata down here showing what coordinates you have, and you can do all sorts of cool things. So you can say, okay, I want to get the data for a particular time, and you can just give it the time as a string, and then you'll see that what you've got back has 2 dimensions in it. The time dimension has been removed as a dimension, but you've still got it here as a bit of kind of metadata, which is kind of handy. If you can't remember what your times are, but you just want to get the time that's in the second time along, as it were, you can use iCell, which is the integer selection method, and you just give it an index like you would with NumPy or whatever as normal. You can do slicing. You can use all your functions like mean, standard deviation, and so on, and do them across axes, where you say, I want to do it across time, or across X, or across whatever. You can even do it across multiple axes at once. In this case, if we're averaging over X and Y, we end up with just having a time dimension and getting the overall average at each time step. And this leads you to what you can kind of have at the end, where you get something quite complicated like this, where you say, okay, here's my data, let's select just 1 year of data, group it by month, and then do a standard deviation over time for each month. And all of that lot in 1 line of code. So this is a lightning talk, so it's very quick. There's a lot more stuff. You can use Dask, if any of you have heard of that. It's a way of doing out-of-core processing and building up processing graphs that can later be executed. This works really well if you store things in a load of different files. It only loads in what it needs to. You've got multi-level indexing, time series operations, pandas, all sorts of cool stuff. Go and check it out online. It's really, really useful, and it saved me a huge load of time this summer. Thank you.
On one, yeah.
Yep. Yes.
There is.
Cool.
If you can.
Hi, a big thanks to the organizers for setting everything up. Just before I start. And this is a cautionary tale in a hardware project that I was doing as a total hobby, and it's a MicroPython keyboard. I'm not a hardware guy at all, and it's a bit of a story. So there are a bunch of ergonomic keyboards that are around that are excellent, and there are a lot of options for anyone who's interested. ErgoDocs is fantastic, and there's a whole bunch of different options. But I always found them pretty tricky because there's always a lot of implicit stuff in them, and bindings are never exactly right for what you want to do, and everyone's got different programs they want to use. Some people use Vi, some people use Emacs, crazy as that might be. So I was having this conversation with a friend of mine, and he was like, yeah, you can make one, it's really easy, just have a look at this guy, Technomancy, he's got this great keyboard, and he's got a great example for you to sort of get started, and that was a good idea, so challenge accepted, I'm going to give it a try. So I went through a bit of a journey, like creating SVG things for cutting out stuff for the board, and for sort of laying out the keyboard itself, and that's really sort of out of my usual experience. You laser the boards and waste a lot of materials. You test out various hardware keys with this thing. It's kind of a cherry key tester. You get all the different options, and inevitably you're going to choose the wrong one, so don't worry about it. Order everything, and then spend about 3 or 4 months assembling and soldering stuff, and then in the end you get yourself a keyboard, and you start putting it together, right? And so this started with a Teensy controller, and I blew a few of those up, and I went through a whole bunch of different options there, and finally landed on a MicroPython board when that came out, and that really changed everything. If I look here, the software journey was pretty all over the place. Started with Arduino, then embedded C, then MicroScheme, then MicroPython, and I can't tell you how
fantastic a difference it makes to be able to use Python on hardware projects. It's incredible. Makes it a lot more accessible. So that's a big shout out for that. Yeah, some hardware gotchas. Give yourself a lot more space than you think you're going to need. Break stuff up if you're lasering into more pieces, and don't go and solder everything yourself manually. It's just too many. 140 soldering points is just a nightmare. So get yourself a PCB or an Eagle file. They're available online. And yeah, so that was that. And then once you've got all of that, you can start looking at the software. So and this is actually the longest part if you're writing everything from scratch. So there's a whole bunch of tools, HID API for the, because it's about compatibility, you need to use the HID protocol, which is kind of drives a lot of the requirements for all of the keyboards being so implicit in their setup. You need a good lookup table, and there's some links and stuff here. And there's a whole bunch of links there that I'll share on later. So the software gotchas, I really wanted to separate my meshes because the keys have to be arranged in a mesh if you want to kind of fit everything on a single controller. But then in the end of the day, you've got to come up with a single hex code. So if you've got multiple controllers and control keys and shift keys, you've got to kind of figure out how to munge those together. Zero-width Unicode characters were an incredible amount of fun because the keyboard was, I had some hard that had the hex key for zero-width Unicode characters, and they were appearing in my code, and I decided to use the keyboard in my actual job, and so I was getting commits which had zero-width Unicode characters in, so that was fun. And there it is. That's the keyboard, and today I released the code. It's been around for maybe a year, but I released the code onto GitHub today, just if anyone's interested. But the main takeaway is MicroPython is great, and I really recommend that. So give that a try.
Places. Okay, next it's Celine with Code for Life, Blocky, Python, and AI.
I am.
Oh, well.
Should we plug that in? Just a moment. Trying to mirror my screen. Fine, it's working. Hello, everyone. I'm Celine from Ocado Technology. I'm the team lead for Code for Life, which is a project to teach children how to program. Ocado Technology, I don't know if you're aware of that, is the technology branch of an online supermarket. So you would say, why on earth are they developing coding games for children? Okay, let's go back to a talk that we might have heard yesterday by Kate Lehman. She asked us, when and why did we learn how to program? So my first question to you is, which one of you, raise your hand if you learned the basics of programming before you were 11? Okay. So that's quite a fair amount of people. That's nice, but you can see that it's still not that much. And actually, as developers, I guess we mostly wished we had learned the basics earlier. We wished we knew more, and also we wish that the new generations have better tools to work with that and can become good programmers if they want to later, right? So in 2014, the UK decided to add computing at the heart of the national curriculum from primary schools, but the teachers were also sort of left alone. It was not that easy, and the developers within Ocado decided to volunteer to create a project to create coding games to teach the children and help the teachers. So we do have a lot of teaching materials for the teachers, for instance, those PDF files, but the core of that are obviously the coding games. So the first game that was created is called Rapid Router. It's really nice because it introduces some concepts with some nice stages. So the first concepts are really basic statements that you program in Blockly. For instance, this one. Is it working? Okay. Okay, just slow. Okay. So the first level is really simple. You have to make the van. So yes, it's an Ocado van making deliveries. Just it's funny. Children love the vans. You have to make a very small step to the house there. So you have to drag the Blockly blocks there. So Blockly is a graphical programming language which looks a bit like Scratch if you're familiar with it, but it's open source. Move forward. Yes. So let's play. Yeah, I've got all the points. That's awesome. And later, we introduce better concepts. Of course, for instance, you have levels like that, but which are really nightmarish, and the van has to go through loops and loops and loops, and you only have the move forwards and the turn left, and you have to copy-paste everything 100 times. It's really painful. So we introduce the concepts of repeat loops, which makes total sense. Let's try to do some live coding in Blockly. I might break the time space with that. I'm sorry in advance. I've got a TARDIS, so it's fine. So for instance, loops and repetition. Repeating yourself is boring. And we have nice videos of people from Ocado explaining what is their day job and what are repeat loops, etc. So it's really nice to teach the kids. Okay, I don't care, I want to play now, fine. So you've got to do the same thing, but you've got access to loops. So here, what you can do is you can say, I want a for loop because I want to move forward 3 times. So, yes, move forward. Oh my God, I didn't break time space. And later on, we introduce Python. So if you go a bit down. So we've got introduction to Python, which is basically programming in Blockly, but then you can see the Python code, so you get familiar with it. And then you can actually program in Python. So let's do this one. So it's the same. You just have to program. I'm not sure if with the microphone it's not going to be okay. So let's go and see another one. But is that finished? I'm not finished.
Okay.
Okay.
Okay. You're over your time, but you have 20 seconds.
Oh, sorry. Okay, okay. Just so quick overview. We are trying to bridge the gaps between that and this, because actually, what you saw from the Python code that we actually didn't see is we don't introduce like classes. We don't introduce frameworks like this one, which is Django. So what do? We are working on a new game for teenagers, which is artificial intelligence in a massively multiplayer game. It's really awesome if you want to help. We're on GitHub. This is our GitHub. We are also looking into talking to teachers, like secondary school teachers. We are also working on an app for iOS, so lots of different projects because. This is my T-shirt. Because as the T-shirt says, Code for Life. Coding is not just for Christmas, it's for life. So that's it. If you want to help, the cheat sheet is here.
Next is Ben Webb, who's on number 1.
Yep. I think I can use this one.
And you got a second to. Are you on? Very good lightning talk. I was very impressed how you used that mic but held the other mic the whole time. Yes. Yeah.
That's
Just in case.
I
Redundancy.
thought it was the sonic screwdriver.
Yes. Perfect. Are you ready, Ben?
I thought so. Is it? Okay. Wait, it's.
I can see you. No, I can't.
You're plugged in. It's all good on my end. What are you using now? You're using VGA still again?
Oh, this one does both. So I've got number 2 HDMI plugged into it.
Oh, okay. Let's see if we can get it up. All right. Where's Rob then?
I'm not seeing anything coming from the laptop. Well, I'm seeing noise.
It's set to HDMI.
Yeah. For you guys over here, they're saying the same thing as me. I don't think the laptop is outputting correctly.
But I set to the other one and it's not coming out either.
Not seeing anything at all.
Can you try and fix it?
Let's forego the switch and let's just come straight.
Oh, then. Fill in a bit. Where's Wes? Wes made the best comment in the world, which was that we were walking out of the venue under the underpass, and he goes, reminds me of Pycon, Coventry. Lovely place, the world's best town. It could just be that we have 2 laptops that don't want to talk to us. Yeah, we're off. We're ready. We're ready. Are you ready?
So mostly I want my slides for this picture, which is a large number. It's $9.5 trillion, which is, if you had dollar bills, it would stretch to the moon and back. And this is the amount of money that gets spent globally on government contracting. And it's roughly 15% of global GDP. So I think it follows fairly obviously that if we care about accountability and transparency of our governments, then having really good data about government contracting is something that's really quite important. And this is where open contracting comes in. Open contracting's a global initiative to push for government contracting to be released openly and openly licensed, as accessible as possible, both to people and to computers, and released timely, so data updated promptly whenever a change happens. And we want to go a step further than that as well. We want to standardize the data model that governments use to publish this data. We call this the Open Contracting Data Standard, or OCDS for short. Now, at the moment, this is primarily about what you'd probably call metadata. The underlying legal text of contracts isn't something we're covering. We're just including that as free text or links out to documents. But we are talking about a reasonable level of detail about contracting, down to the level of what specific items are being tendered or contracted and how many and how much they cost. So how have we decided what fields are in this standard? We've looked at what existing contracting systems have in them, but we've also tried to look at what the user needs are for this sort of data. And there's a bunch of different categories for this, and the most obvious things you want to do with this data is around detecting corruption and monitoring the delivery of contracts. But this data is also really useful if we can distribute it better to level the playing fields for small businesses, make it easier for them to compete in government contracts, and to try and get the best value for money for governments. So there's a bunch of steps to a contracting process, and OCDS is about modeling all of those. And this is a bit different to how a lot of government contract systems work at the moment, where there'll be one system for tenders and bids that people interact with, and a completely different system that will be publishing information about what actual contracts have been signed, and possibly another system for how implementation is actually monitored. And this can make it quite difficult to analyze that data and link all of those up. So one of the big parts of the standard is having a common identifier for a whole contracting process, and then all these different systems can talk about it in the same way, and we can connect it all up. So the actual standard, our main serialization's in JSON, because it's a nice developer-friendly, well-specified format, and we've got it all defined in JSON schema, so we can do validation, and also all our documentation comes from that. And so who's using OCDS? So on this map, all the countries in purple actually have government bodies that are publishing some OCDS data already, and the countries in the sort of greeny color are actively working on implementation. And a bunch more have committed to doing this. Considering this OCDS was launched 2 years ago, we think this is pretty good progress. And if you're interested in this sort of data or otherwise helping with the project, we've got a sprint tomorrow. Thanks.
We dismantled the world because that laptop wasn't liking the switcher.
Maybe this one will like it, you never know.
Yeah.
Let's have a look, see. If not, I will enable VGA.
Do it in one voice otherwise.
Otherwise, I will just have to out. That definitely doesn't work yet. Still, you know what they say, to err is human. To really fuck things up requires a computer. I know, it's tradition. First Pycon I ever came to, I think I spent most of it watching Max refusing to talk to the overhead projector, and now here I am, struggling. Hey! What do you know? So let's flip that over there. Do that. And I think, provided I can stop this sliding off the desk, we're away. Right. Who here has ever used either of these two calls? Get address info and get name info. I imagine quite a lot of you. They're part of the Python standard library. They're what you use for looking up names and looking up addresses in the domain name system. Well, wrong button. Has anybody ever wished they could do that asynchronously? Because, of course, when you issue those calls, you then have to wait until the server comes back to you, or even worse, times out. Now, advanced questions. Who's heard of DNSSEC? Well, hey, this is brilliant. Last time I asked that question, I had about 2 people going, You lot are obviously far more intelligent and well-read. For those of you who don't know, DNSSEC is technology that's coming. It authenticates that the answer you got from your DNS server was really correct, and that you haven't had someone mount a successful man-in-the-middle attack. Now, the last question for real bonus points. Has anybody heard of DNSSEC Dane? Haha, brilliant, brilliant, brilliant. Right, this is using using DNSSEC to deliver certificates or information about certificates. Yes, at some stage it might be possible to escape from certificate authorities. However, if you want to use this stuff at the moment, you have a problem, because the existing get-addr-info and get-hostname calls use the built-in C library, I believe. And there's a problem because that doesn't do all the new stuff. There is, however, an answer, and this is here what I'm here to plug. Okay. GetDNS is an application-level library that's written by the same people who write your DNS servers, but is intended for use in applications. And it can do all these new and wonderful tricks, starting with asynchronous queries. Now, one of the nice things about GetDNS is, although it's written in C, it returns its results in dictionaries. Does anybody here know a language that's good at dictionaries? Because I can assure you that C sucks dead rats down a garden hose when it comes to you dealing with dictionaries. Let me introduce Melinda. Melinda is wonderful because Melinda has written a Python wrapper for GetDNS. And here you can see it in action. And look, dictionaries all over the place. It's wonderful using GetDNS from Python. It's almost like it's been invented for that. Even better, if you want to know more, Melinda gave a half-hour presentation to Pycon in the States earlier on this year, and it's on YouTube, so you can hear about why you should be using this, or the circumstances where you might consider using it. Okay? So, if you want the very latest in DNS technology, if you want to do asynchronous calls, and if you want to do it from Python, GetDNS. Remember it. Thank you very much.
Thank you to all our Lightning Talk speakers. And I'd just like to welcome the 2016 local chair and the committee chair to sum up the conference. But before we do, I'd just like if you could give them a standard ovation, if you don't mind. If you think it's a good conference. They have done so well. It's gone so well. And over to you.
Thank you very much, Zeth.
Thank you. So well. So good. Best Pycon by miles.
Where's the HDMI?
This one. This one here. This one here. HDMI.
Are these microphones on? Yeah, give me this one. Okay. So, we're just about to wrap up. Peter and I will share this because we've got a few things to say each. Just want to report on the code of conduct. We had, just so you know how it works and what goes on, during the conference we had 2 complaints made, both today, that we treated as code of conduct issues, and they both concerned discourteous remarks that were made during the questions after a speaker's talk. So we just want to remind our audience members that informing the speaker that she is doing it wrong, even if those are not the exact words you used, is not an example of respectful behavior, and it's not welcome at Pycon. Similarly, calling out answers to another person's question is not respectful, and neither is dismissing another person's remark with "that problem was solved 20 years ago," or similar words, again, is not respectful or welcome here. So please bear that in mind. it's not the end of the world to do something that's a bit discourteous, but please try not to do it again. So that's our It's the end, or very nearly the end, because it's the end of our talks track. Tomorrow we have sprints and workshops, and they'll take place here. Peter's going to tell you about the sprints.
Just briefly, there's a page on the website that explains what sprints are and how to get involved. It's linked to from the homepage. It'll explain far more eloquently than I'm capable of right now. So I'm going to hand back to Daniele.
Is that all you're going to say?
If you would like to give a sprint in the morning, you should turn up at 9 so that you can stand on this stage and speak behind this microphone and let the rest of us know what you'll be working on so that we can come and join you.
So it's time for the thank yous. We have many, many people to thank. So what I'll do is I'll just mention them and we can thank them all in one go, unless you can't contain yourself from bursting into applause in the meantime, otherwise it might take a bit while. So firstly, our sponsors, large and small, every single contribution has helped us make this event affordable and has helped us to do the things that we've done, like put on the speech-to-text reporting or hold the creche. So thank you to our sponsors. Thank you to all of our speakers and workshop leaders. If you counted up how much time has been put in the preparation for this event, it would probably run into many weeks, months or years of people's time. So thank you to everybody who's offered themselves up. Thank you to the speaker mentors who helped some of the first-time speakers or speakers who just wanted a bit of help prepare their talks. Thank you to our Lightning Talks chair, Zeth, wherever he may be. Thank you, Zeth. Thank you to our tireless film crew. Tim Williams, please stand up. Thank you to Luke Stanley and the helpers. Thank you to our STTRs, Cheryl, Hilary, Morella and Sam. Thank you to Rob and Alex from Enthusiasm Events who've provided AV support here in the assembly room. Thank you to all the staff here at City Hall. They've been fantastic over the last few days and they've helped us sort out every problem. They've been absolutely fantastic. All these people that I've mentioned, or most of them, we've also mentioned them on our Twitter feed, so please retwitter that and say thank you to City Hall, to Enthusiasm Events, to the creche and so on. Finally, thanks to you, our attendees, because you're not just an audience, you're truly participants in this. You're always ready to help out by lending a hand, whether it's as camera persons. There's one of our keynote speakers standing behind the camera because he wanted to help. Helping as session chairs or coming forward at any time something needed to be picked up and moved somewhere else. Can I help? So thank you so much for that. It really means a lot to us and it makes a big difference to the kind of event that this is. And thank you also for coming to Cardiff. I live in Cardiff, and it's like having everybody come round to your place for a great big party. And finally, can we have every one of the committee and volunteers up here, please? Right now, please. Because our volunteers have worked tirelessly for this, and every one of them has done it for the pleasure of doing it. So please thank our volunteers, please, as loudly as you can. Thank you so much. If you just duck away from there, we'll be back here around about this time next year at Cardiff City Hall, Pycon UK 2017. So see you tonight, or see you tomorrow, or see you next year. Thank you very much. Thank you.